Hi guys, this is the 1.3 notes on piecewise defined functions. So piecewise functions are, it's really one function consisting of multiple functions that create that one function. Okay. So what I mean by that is if you look, right, we see three kind of functions right here. And we also see certain intervals for those functions. Okay, so what we're going to do is draw these three functions, but we're only going to represent it for its interval. Okay, so what we're going to do is sketch the x values of this smaller function, right, for the interval from at -10 to -2 for this function here. Okay, this is a linear function, so we're only going to graph this for the x values from -10 to -2. Okay, so -10 to -2. All right, so what does 4x plus 11 look like? Well, if you think about it, it's a line with a slope of 4 and a y-intercept of 11. Okay, so right, this is a 3, this is 6, 9. Right, so 11's about right here. Okay, and then we're going to go down 4 to the left one, so 7 is about here, right here, and then we're going down 4 to 3, and then 1 right here. All right, now, right, we can erase these 2 points to the right because they're not on the interval from -10 to -2. They were just there written to help us graph. That is not erase. This is erase. Okay, now we're going to continue this pattern all the way to -10, so down 4 to the left one, and if you keep going down 4 to the left one, you're going to get, when you get to -10, or you're going to be at -10, -21. So right here is -21. So I'll graph from -10 to -2. So -2, 3, -10, -21. Right, you could do all the points and you'd see a bunch of points on this line, right, if you go down 4. But I'm just going to kind of give it to you. Right, so this is the line. This is 4x plus 11 from -10 to -2. Okay, now we need to draw the parabola here, x squared minus 1 from -2 to 2. Okay, so right, we just did transformations, right? So we know this is saying our k equals -1. So we're drawing x squared down 1. Okay, so we're going to draw the x squared, but we're going to move down 1. So down 1 is about here. And then we're going to up 1 to the right one. Up 1 to the left one. All right, and it's going to kind of continue like this. And then continue like this. Okay, so that's our graph of x squared minus 1 from the interval -2 to 2. Okay, and then the next one, we're going to draw x plus 1, right? And that's only for 2 to 10. Okay, so we're looking at 2 all the way to 10. Actually, 10 should be out here. Okay. All right, so let's draw this out. So this has a slope of 1 over 1 with an x-intercept of 1. So technically it's starting right here, and it's going to go 1 over 1. So it's going to meet at here, and then it's going to go up 1 to the right one, all the way, right? So we're going to go our 10 point, right? If you plug in, so say you plug in 10, it's going to be 10, 11, right? So 10, 11 is right here. This was 2, 3. And that's what our line is. Okay. And now, so what we're looking at is, see how it's 3 different smaller graphs all put into one function. Okay. So it's a bunch of smaller functions put into one function that we call f of x. Okay. That's essentially what graphing piecewise functions are. Okay. Now it asks, what are the domain and what is the range? Okay. So domain is all our x values. Right. So our domain starts at -10 and ends at +10. So our domain is -10, 10. Right? And if we wrote it in the other form, you could also write x is less than or equal to 10, -10, which is less than or equal to +10. And then our range is all y values. So our lowest point is -21 right here, and our highest point is 11. Okay, so okay. I'm sorry. All right, I'm sorry. We're gonna have to refix this first graph. I messed it up. It should not be 21. It should be 29. Okay. So I'm gonna actually erase that. I'm sorry. I hope you can erase this too. Okay, it's not letting me erase it. There we go. I knew something was off. Sorry about that. So I'm gonna Okay, my buttons aren't working. Okay. Redraw this. It should be -10, -29. I apologize for that. So that makes our lowest point actually -29 for a y value. And then our highest point is at 11, right? At 10, 11. Right, and we can also write that as y, right, is greater than or equal to -29, which is less than or equal to 11. And that's your domain range. So I'm sorry about that. It should be -10, -29. I think I saw what I wrote. All right, so this one we're actually going to do part A together, and then I'll let you do B on your own. So this one goes from -6 to -2 for 2x plus 5. Okay, so we're looking at from -2 to -6. Now we have a y-intercept of 5, so it starts here. And then we have a slope of 2 over 1, so we go down 2 to the left 1. Then down 2 to the left 1, and it hits right here. Okay, so it hits at -2, 1. Then we go down 2 to the left 1, right here, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1 here, which hits at -7. Oh, sorry, -6, -7. Okay, so there's our graph of that one. Next one is a parabola, right, from -2 to 1. All right, so -2 to 1. Okay, so first find our vertex. Well, our h is 0, so we're not moving left to right, and our k is -7, so we're going down 7. Right, so down 7 would be at -7 here. Okay. Now, right, let's test out -2 and 1 and substitute them in for x to find our y values and find those 2 points. Okay, so if we substitute in -2, right, if x equals -2, we get 2 times -2 squared minus 7. So -2 squared is 4 times 2 is 8. So 8 minus 7 is 1. So we get -2, 1. Then, all right, if we test out x equals 1, we get 2 times 1 squared minus 7. 1 squared is 1 times 2 is 2. So 2 minus 7 equals -5. It's 1, -5. So let's plot those points. All right, here is -2, 1. And then here is 1, -5 is right here. So we're going to make our parabola like that. Last one is from 1 to 3. So from 1 to 3, we have this right here. So it's at -4. And we have a slope of -1 over 1. So that means we go down 1 to the right 1. Right, and there's our point for 1. Okay, so this is 1, -5. Down 1 to the right 1, down 1 to the right 1 gives us our point at 3. So 3, -7. Here's that graph. All right, if you want to clean it up, you can erase the extra points that we made, maybe. Sorry, my computer does not work. Those are the extra points that we made to draw those actual lines, right? And that is your graph. Okay, so what I'm going to have you do is try the next one on your own. All right, so we look at this, right? This says graph from -4 to -1, from 0 to 2, and from 2 to 4. Okay, this is just saying y equals 3 graph, right? So that's a straight horizontal line at y equals 3. Right, this one has a slope -1, right, and a y-intercept, which we call b of 0. This one has a slope of -1 and a y-intercept, which we call b of 3. So that should help you with this. So try this on your own, pause it now, and then I'll go over the solutions. All right, guys, here's the solutions. Right, so remember, here we have an open circle because it's not including. This one we also have an open circle. Right, and this one we have an open circle. So there's some key things to look at. Right, the graph of y equals 3 is right here. Right, it's just a horizontal line from y equals 3, and we said it's from -4 to -1. Right, but it's open here because it's not including it. Our next one is from 0 to 2, including both, so they're closed circles, right, from 0 to 2, and it's a graph of -x, so down 1 to the right 1, down 1 to the right 1, and that's what it looks like. And then the last one has a y-intercept of 3, and then down 1 to the right 1, down 1 to the right 1, and it starts at 2, and it's an open circle because it's not including, and then keep going down 1 to the right 1, down 1 to the right 1, another open circle there because it's not including it. All right. And if we want to say what intervals it's increasing at, right, it's not increasing at all. There's no slope that's positive. We have negative slopes, right, here and here. So it's those intervals, right, this interval here and this interval here, they're both decreasing because they have a negative slope. And then it's constant right here from -4 to -1 because it is constant. The slope is going from left to right. There's no change in slope, right? The slope equals 0. All right, so now in these ones, we're actually going to be writing rule given the graph. Before we were given the rule, we wrote the graph. We're going to work backwards in this case. Okay, so our first step is to find the domains of them, meaning those intervals that each part of the piecewise function is looking at. Okay, so if we look at segment A right here, right, it's starting at, if you look, they're going by twos, so it's starting at -2, right? It's including it, so it's less than or equal to, right? And then it goes to here, which stops at 1, and it's an open circle, so it's just less than 1. Okay, so this interval is from -2 to +1, but not including +1. So this is what our domain would look like. Okay, so that's the interval. Let's move to the next one. The next one starts at 1, it includes it, and ends at 5. So 1 is less than or equal to x, which is less than or equal to 5. Okay, and then the last one, right, is not including this. It's technically an open circle because the red graph is taking that over. Okay, so this is an open circle at 5, right? So 5 is less than x, and then it goes to +8, so less than or equal to 8. Okay, so these are our domains, right? These are the intervals that we're looking at. Okay, then you need to figure out the slope. Well, in this case, I gave you the slope here. Part A has a slope of 3. You can tell it goes up 1 to the right 1, so m equals 3. So slope is 3, or m equals 3. The next one goes, so that technically went up 6 to the right 2, which reduces to 3/1. This one, right, up 1 to the right 1, or it goes up 2 to the right 2. Either way, your slope is 1, so your m is 1. And the next one is a horizontal line, so your slope is always 0 for a horizontal line. Okay, now we're going to use these slopes to figure out what our y-intercept is. Okay. Okay. Now, so like I said, we're going to use that slope. And what we're going to do is we're going to use our y equals mx plus b. So y equals mx plus b, right? That's our slope intercept formula for a line, right? These are all just lines, they're not parabolas. So we're going to use those to figure out our y-intercept, or our b. So what we're going to do is we're going to pick a point on the line, right? So the blue line, right, we can see one of the points is 1, -1. So we're going to use that point for our x and our y. So we're going to plug in 3 for m, 1 for x, and -1 for y. So -1 equals 3 times 1 plus b. So -1 equals 3 plus b. Therefore, b equals -4. Right? So if b equals -4, we're going to rewrite this as y equals our m, our slope, which is 3, times x, and then plus b, or -4. We do the next one, right? The next one, our domain is from 1 to 5. We know our slope is 1, right? So y equals mx plus b, where our m is 1, and our point we have is 1, 4. Right? You can see it right here. We can use that point. Right? You can pick any point on the line, but these ones are given on the graph, so we're just going to use them. Right? That's your x and y. So 4 equals 1 times 1 plus b. So 4 equals 1 plus b. So b equals 3. Therefore, our function, right, is y equals x plus 3, or 1x plus 3. And then the last one, right, y equals mx plus b. Right, you should be able to pick this off right because it's a horizontal line, and know that it's x equals 8, right? Because it's at f of x equals 8, because y equals 8. But we can go through them, right? A point is 5, 8 on this, right? And our m is 0, so you're just going to get 8 equals 0 times 5 plus b, so b equals 8, right? And we know our mx is 0, right, because there's no slope, so f of x just equals 8. Now what we're going to do is write the final rule. So we're going to take out the f of x, right? So y, we don't have to write the y because f of x is written there already. So f of x equals 3x minus 4. Also, f of x equals x plus 3. And then f of x also equals 8. Now we're going to write the interval for 3x minus 4. We said the domain, right, is -2 is less than or equal to x, which is less than 1. For x plus 3, we said it's positive 1 is less than or equal to x, which is less than or equal to 5. And then the last one for f of x equals 8, 5 is less than x, which is less than or equal to 8. All right, so this is our rule for this piecewise function. All right, so now what you're going to do is you're going to try these on your own. Okay, so do exactly what we did in the last one, right? You want to first find the domains for the first graph here, the next graph here. So for all 3 parts, right? And this is technically your intervals. So they're intervals that are graphed, right? So you know your first one goes from here to here, right? Which should be -5 to -2, right? So that should be your first interval, okay? So you're going to try this on your own. I'm going to give you the solution and kind of run through the answers. And this is the setup for B, right? So again, right, find the intervals. Okay. So again, 1 was find intervals. I didn't finish writing the rules. 2, what you want to do is find y-intercept and slope. And then you want to find what f of x is equal to. And then last thing you want to do is write the rule. Okay, so pause this now, try these 2 problems, and then I'm going to go over the solutions. All right, so now you can see this is the solution to A. The first line is f of x equals 7. All right, so essentially what that came from, all right, we know the interval is from -5 to -2. And then you should know it's a horizontal line at y equals 7, so that's why it's just 7. The next one, you can see the y-intercept, so you don't necessarily need to solve for b. You can see the y-intercepts at +5, and then our slope, right, is -1/1. That's where you get this x plus 5 from the interval -2 to -3, because it goes from -2, not including it, because the last one included it, all the way to including 3. The last one's interval is from 4 to 6, right? It's not including 4, so we have just less than, right? X is greater than 4, right? But it is including 6, so s is less than or equal to 6. And right, for this one, right, our slope was 2/1. So, and then you can use the point 4, 5 if you want. All right, 4, 5. So we use 5 is equal to, slope is 2, and then our x is 4 plus b at 8. So b is equal to -3. Therefore, our -3 is here. So our y equals mx plus b is 2x minus 3. For part B, right, from -3, not including -2, right, we have a slope of -1/1, right? And if we continue that down, we could see it's going to cross the y-intercept at 0. That's why there's no b there, right? But you could also actually solve it. It's up to you. And then the next one is a straight horizontal line at f of x equals 1 from -2 to 1, not including 1. Right? And then the last one, right, we have a slope of 4/1. So our slope is 4. Right? We have a point at 1, -1. So -1 equals 4 times 1 plus b. So 4 equals 4 plus b equals -1. So -4 equals b. Or sorry, -4, -5 equals b. So that's where you get the 4x minus 5 from. And that's from interval 1 to 2. Right? And that's including both because they're both closed circles. So if you have any questions on this, let me know. Also use the extra help videos to help you on this as well as for the worksheet in Math Excel.